called mole fraction. It is related to expressing concentration terms. So here we are dealing with mole fraction, which is obtained for both solute and solvent, and it is the ratio of number of moles of solute, or it may be taken as solvent, to the total moles, that is solute plus solvent. Mole fraction notation is chi, that is x. Now suppose if you want to find uh, the mole fraction of solute and solvent, so this can be written as, that is xa, that is mole fraction of solute. If I say xp, that will be mole fraction of solvent. Now xa can be given as, that is number of moles of A, that is solute, to the Na plus Nb, that is total number of moles of solute and solvent. Now for moles of solvent, mole fraction of solvent, it will be written as Nb upon Na plus Nb. In this way we can find the mole fraction of solute and solvent. So let's do few numericals related to it. That is, let's take an example. Suppose the question is 4 gram NaOH is dissolved in 90 gram of water. Find mole fraction of both solute and solvent. So here given, that is weight of solute, which is 4 gram. Now molar mass of NaOH, that will be 40 gram per mole. For water, that is W for solvent, that is 90 gram. So its molar mass of S2O, that is 18 gram per mole. Now let's find number of moles of solute, or it can be written as NaOH, that will be 4 upon 40, and that will be 1 by 10. Now that for solvent, it can be written as NS2O, and that is 90 by 18, and that will be 5 moles. So these are number of moles. Now if I have to find mole fraction, so that will be X NaOH, and that will be NaOH upon NaOH plus NS2O. So it will be given as, that is NaOH, it is 1 by 10, that is 1 by 10 plus, that is 5 moles, that can be written as 5 by 1. On solving, one will get 1 by 10, that will be 1 plus, and that will be 50, 10 5 is 50 upon 10. Now it can be written in decimal. So if you write in decimal, it will be, that is 0.1 upon 0.1 plus that will be 5. It will be 0.1 upon 5.1. So this can be solved as x NaOH is equals to 0.1 upon 5.1. On solving, will approximately gets that will be 0.0196. So this is mole fraction of XNaOH. Now sum of the mole fraction of solute and solvent is always equal to 1. So we can say that XA plus XB will be equal to 1. It may be empty number of terms, it may be many terms, B, C, D, E, F, G, H. So we can say that XNaOH plus XS2O will be 1. Now XNaOH we know it is 0.0196 and we have to find if XS2O it will be 1. So XS2O on subtracting 1 minus 0.0196 will get XS2O as it will be 0.9804. So this is our mole fraction. In this way we can find the mole fraction in a given part. Let's take another question. That's question number 2. If 13 gram of benzene is mixed with 22 gram of carbon tetrachloride, find the mole fraction. Find the mole fraction. So it's simple. Let's find given. So that is now WC6S6 is given as, that is for benzene it is 13 gram. Molar mass of C6S6 and that will be 78 gram per mole. For carbon tetrachloride it is given as WCCl4, it is 22 gram and molar mass of CCl4 that will be 154 gram per mole. Now we have to obtain number of moles above, so NC6S6 will be WC6S6 upon its molar mass and that will be given as its molar mass. So it will be given as 13 upon 78 and it will be 1 by 6 mole. For carbon tetrachloride this will be 22 gram upon 154 and it will be 1 by 7. To move further we have to find mole fraction of if C6S6. So we have to write it as NC6S and the total moles of solute and solvent and that will be NC6S6, that will be C6S6 plus NCCl4 and that will be given as 1 by 6 upon 1 by 6 plus 1 by 7. So in solving we say that 1 by 6 upon cross multiply, that will be 7 plus 6 upon 6 into 7 and this will be given as C6X6 1 by 6 and that will be 7 6 13 upon 6 into 7. So on solving further 1 by 6 into 13 and 6 into 7 will go up, 6 and 6 will cancel out, it will be 7 by 13. Now we can solve 7 by 13. It is 0, so it will go 65, 5, and it will be, sorry, it will be 13 3 ja 39, 9 1 1. So it will go, so it will be 0.538. That will be a small fraction. So here S6 will be given as 0.538. So if you want to find that is small fraction of CCl4, so it will be 1 minus, and that will be mole fraction of C6S6, and that is 0.538. So it will be 1 minus 0.538. So on subtracting we'll get 29364. So it will be 0.462. So in this way we can find mole fraction of a given solute and solvent.